Could you just go over how you would know if there's like an asymptote, and if there is, how would you like find it?
Do you have a particular one, like a horizontal asymptote, vertical asymptote, or both?
Both.
Okay, let's try that. Finding horizontal asymptote, vertical asymptote of a function. I will give you something universal. X squared minus 4, x squared minus 2x plus 8 and minus 8. Okay. To do this type of problem, you have to be very clear on what you are looking for and how to do it. The actually doing it is really easy. Okay, the harder part is knowing what to do. So let's make it clear. For horizontal asymptote, you check two things. And your answer is going to be at most 2, maybe no horizontal asymptote, or 2 horizontal asymptote, or 2 horizontal asymptote are the same. So instead, you have 1. For vertical asymptote, you are looking for something like a constant divided by 0. Sounds good?
Yep.
Let's try each one. Let's try the horizontal one. Okay. Limit x goes to infinity. X squared minus 4, x squared minus 2x minus 8. If I ask you to show the work, you divide by the leading term. By this, you can just look at the leading term, which give you 1. Okay. Similarly, if you try this, which is also 1. Therefore, your answer should be the horizontal asymptote. We only have 1. Y equals 1. You don't have to draw it. I'm just drawing it to illustrate. What we have here is basically, as time goes by and as time track back, they both go to y equals 1.
Okay, that makes sense.
Now for vertical asymptote, we're looking for a constant over 0. So the first step you should do is, you should really take this one and set the bottom to be 0. Once you have that, you have 2 possible candidates. But keep in mind, what I just did is I set the bottom to be 0. So I guaranteed you are dividing by 0, but you don't know it's going to be a constant divided by 0 or 0 over by 0 yet.
Right. Okay.
Because this may be a whole, which is not a vertical asymptote, which can be trouble. So your next job is try to check, does any of them give you a 0 over 0 case?
Right.
Okay.
So you just plug it back in and then see if
Plug it back in, and you can see this one doesn't work.
Okay. Okay.
The
So
vertical asymptote is x equal to 4. That's how we do the second one.
okay, thank you.
Cool. For some of you guys, if you don't like this, there is certainly a shortcut to do it. That is, try to exclude this case from the beginning. Then what you can do is you can actually do the factoring here. Now you know clearly, number 1, 4 is good. Number 2, because they are the same, this one is not good. Then in this way, you kind of verify and find at the same time. So you don't have to find it first and then verify. You can see only this one is working because this one basically got canceled on the top. Okay. I will take either approach. Personally, I think the second one is more, is a little bit more faster. But I mean, the first one is okay too. Cool. Very good question, by the way. The exam will have something very similar. Okay. Other questions?
Could you? Oh, I'm sorry, I didn't raise my hand. But Could you
Well,
go for number 31 on 2.6, please? I kept getting the same ones wrong and I couldn't figure it out.
yeah, just wait a second for me to type in your name. You didn't go with Addie in WebWork, so. So I can find yours. Yep, here. 2.6, 31. Hmm? Oh, okay. Let me share my screen. Can everybody see my screen? All right. So here's the thing. For a function whose graph is given, state the following. Okay, negative in does not exist. All right. The first one is limit g x goes to infinity gx. That's the horizontal asymptote on the right. From here, you can see it's y equal 2. So 2.
Oh, okay.
I'm hoping. Yeah, they didn't say, but okay, yeah, 2. Negative infinity, that's here. Horizontal asymptote, that is negative 2.
Oh, I just looked at it all wrong. Okay.
Yeah. X equal to 3, that's here. You have a positive infinity on the left and right. Therefore, positive infinity in a whole overall. X goes to 0. You have a negative infinity because both go down. X goes to 2 plus gx. 2 is here, plus is roughly here. I'm going to guess it's 0.7. Right?
Doesn't go to
Something like
negative 2.
Oh, negative 2 plus. Great. Okay, that's going to be negative infinity. Thank you. Man, I'm getting old. Okay, I believe you got the second one right, so you should be. What are they asking for the second part? Oh, asymptotes. So yeah, cool. One thing people may get confused is negative 2 here. Do we have an asymptote? Well, on the left we don't. On the right we have. If you only have one side, you still have an asymptote. Okay, even though this side doesn't, on the left, this one doesn't go to the infinity or negative infinity, but on the right it does. It's still a vertical asymptote.
Okay. On the test, sometimes it asks, write the asymptotes in increasing order like it did here. If you mess up the order, do we get points off?
If I ask you to do it in increasing order, then if you mess up with the order, I would dock the point off.
Okay, sounds good.
But I won't ask it, so
okay.
Yeah, just some hint. Spoiler, actually. By the way, I won't tell you what's going to be in the exam, but somehow if you did your work and you figured it out, sometimes I may tell you yes or no. Like, yes, it will be an exam, or no, it won't. Okay, so it's really on how much effort you want to put into it, and I will consider it and give you some small hint. But I won't do that thing voluntarily. You need to squeeze that information out of me. Okay, that's where the fun is, right? Okay, other questions regarding the exam, homework, quizzes? Nick?
Yeah, I'm still kind of confused how to write precise definitions.
Good question. Number one, this is kind of not required, like not the key point of the class, but I want you to have exposure. Therefore, I only have one way to ask the question. The exam will be exactly this way, okay? The question looks like, write down the precise definition of limit x goes to 3, x squared equals 9. This part may change in the exam, but the question looks exactly the same, okay? Just a different limit, okay? And all you need to do is just memorize or understand, or either way, just say the precise definition. This is how it is said. For any epsilon bigger than 0, there exists a delta such that if delta, then this will be the answer, and you receive the full point. Ideally, I want you to understand the logic, like why this is delta, not this is delta, or why do you put 3 here and do you put 9 here? I want you to know this logic, but for the worst case, at least you can memorize it, which is not hard at all. If you want a shortcut, basically the bottom goes to the if part, and the top goes to the then part. Okay, but I would strongly suggest you don't go that way unless you're desperate. Okay, try to understand the logic here. The key is try to let you understand and read this thing. Cool. Others? All right, let's continue with what we left over from 3.1. Keep in mind, we're trying to do the derivative of everything. Okay, we start with simple functions, then we do the rules. The first one is polynomial and exponential. Okay. This is how we did polynomial. Number 1, we do power. Okay, so first we realize the easy ones are constant has a 0 changing rate, and a straight line has the changing rate to be the same as the slope. Number 2, we did a lot of FOIL things out, but finally, by difference quotient, we figure out a formula that is, this works for any power. Real number, which helps us to handle x to the cube, x to the 1/2, x to the -3. Anything that looks like a power, we can do it. I point these two out because usually we don't think them in powers, but really next time you see a root, it's a power. You see 1 over x to the cube, that's a power. That's a negative power. All right, that's good. Then we start to ask a question. This is power, but how do we get polynomial? Suddenly we realized, well, this is a polynomial, but a polynomial is nothing but a lot of powers putting together. For everything I circled, I know the derivative. Still okay? But then the question becomes, if you know the derivative of this, how do you know the derivative of 3 times x squared? Okay. If you write it down, it's basically if you know f, how do you know cf, which is f times a constant? Second, if you know x cubed equals 3x squared, you know x squared equals 2x. How do you know the derivative of x squared cubed plus x squared? From here you can see that's of knowing f and g, how do you find f plus g, and of course f minus g? Make sense so far? Therefore, to finish this, we need a rule for the two things I just wrote down. Luckily, the two thing works. That's the differentiation rule. And at least we have two of them. F plus minus g prime equals f prime plus minus g prime. Second, you times a constant, just leave the constant and do the inside. Now if I write down any polynomial, technically, number 1, I have 3. Let's do them separately. But now we know this is fine because of the rule 1. You have a plus, you have a minus, you can do the individual part. Second, what about this 3? By rule 2, it tells us you can ignore the 3, just do x to the 6. Ignore the 4, just do x to the cube. Ignore the 6, just do x. Guaranteed by the second rule. Then together, this thing should be clean now. Use the formula. The thing I circled is the n in this formula, x to the n prime equals n x n minus 1. Just in case. Finally, finish. Something's wrong. Oh, here, it's a 1. Okay, plus 6 times x to the 0 is nothing but just a constant. So this is what we got. Sounds good? Okay. It works as we expected. So there's no special caution here. Just go ahead. You feel good, you just do it. Okay. Later when you do it, because this is so easy, you don't have to write down which rule you used. For now, I just write it down for the notes. Let's try another example. What is the derivative of this? Let's just do this one. Oh, Jordan.
It's a super quick question. So can you go up a little bit? Like scroll up on your thing. Do you want us to write out that like step right before you got the answer, or can we like skip that?
Actually, later everybody will just jump directly from here to here because it's so. Oh, sorry, not this one. Directly from here to this block here because it's so easy.
Okay.
So for now, as long as you don't confuse yourself, feel free to skip steps. I just want you to retain a ability that is, if things go wrong, you will be able to backtrack and see where things went wrong. Okay. So you don't have to write any of this except for the last example, last thing. Another thing is, if you just jump ahead, you get the answer, and if you get it wrong, I cannot give you partial credits. I don't even know where to find partial credits, right? So there's always an advantage to write things out, so I can give you partial credits. And there's another practical reason of why you want to write everything to the detail, because what if you finish this thing halfway and somebody come here and try to pick it up? You want to write the thing in a certain way that every other human being can read your work and continue. Okay, so even though you think, well, sometimes I'm just too smart to write down the steps, think about you're doing it for other people, especially for me. Okay, so I know, did you get it or did you just guess it? Okay. Because frankly speaking, for all the problems we have from the applied problem, if you guess the answer is going to be an integer, if you guess the answer is 1 and 3, usually you will get it right. Not because you're super smart, it's because I use easy numbers. I don't want you guys to use a calculator in the exam. So don't just go ahead and say, hey, I think the answer is 3. Okay, no step. I will not give you a score for that. Okay, cool. All right, how to do this? Well, it's easy. Do you know the derivative of this? That's 3x squared. Do you know the derivative of this? That's 2 times 2x, 2 minus 1, which is 2 times 2x, which is 4x, plus a 0. What about these two multiplied together? That's just 3x times 4x, which is 12x to the cube. Make sense here? Super easy, right? Good, good, very good. Now, I want to say a thing to mention. That is, I can go a different way. I can first FOIL everything out, right? And don't take the derivative. Let's first FOIL everything out. Yeah. And if I do things this way, I should get the same answer because it shouldn't depend on which way I do it, right? What's the derivative here? It's 10x to the 4 plus 6x squared, which is different from the answer you got here. Makes sense to everybody? So question here, which one is correct? Answer yes if you think this one is correct. Answer no if you think the bottom one is correct. After you choose, you should think about why the other one is wrong. If you choose yes, think about why the bottom one is wrong. If you choose no, think about why the top one is wrong. Four, 5, 4, 6, 7, 6. Oh, 5, 6, 6, 6, 7, 6. All right, let's pick a yes. Let's go with, let's see. Let's go with Nick Peterson. You answered yes. I don't want to ask you why a yes. Tell me why this one is wrong.
Okay, that one's wrong. Okay, so I took calculus in high school, so I know the product rule.
Which one did I use the product rule?
For the top one, because it's the derivative of the first times the derivative of the second.
Okay, so basically you're saying like the top one is correct because we have a product rule which do this, right? And I follow exactly the rule. Therefore, the top one is correct. The top one is correct. And the second one is not the same as the top one. Therefore, it's wrong. Therefore, you're betting all your money that you memorize the right rule. Okay? It will be way better if you can say why this one is wrong, but let's keep it that way. People who answered the second one is right. Basically means people who answered no. Jordan, why the first one is wrong, you think?
I guess I don't know. It would make sense that you'd have to like FOIL everything out and then do it, because it would be the same as just a regular, like if you gave us 2x to the 5th plus 2x cubed, it would be the same thing as if you gave us x cubed and then multiply.
So your argument is the bottom one cannot be wrong.
Yeah, I don't know why.
You don't know why the top one is wrong. Okay, yeah. Great. Everybody roughly the same idea, same vision here, right? Okay. If I were you, I would go to the, I don't know, the library or dictionary we have just did. This one followed what? This one followed several things. Number one, FOIL cannot be wrong. Number two, the rule of f plus g, f minus g, and the power rule cannot be wrong. And that's the only tool I used. Therefore, the bottom one cannot be wrong. Good so far? Otherwise, you're challenging the rule. One of them. But all of them are in our dictionary already. Sounds good. Now the top one. What did you do for the top one? Well, you use the power rule, which cannot be wrong. We just did it, right? Then you use something called a product rule. Now, if the top one fail, the only possibility will be this one fail. Still okay? But this one looks so natural. So is this one correct or not correct? That's at least something questionable because the other two is unquestionable, right? We just did them and they're right. Is this one correct? Let's try some easier examples. f dot g. Let's take f equals x and g equals x. If this rule is correct, then x times x prime should be x prime times x prime. What is x prime? 1. The other one, also 1. I should have this answer if this rule is correct. Make sense so far? But what are you trying to do? You're trying to tell people the derivative of x squared, which is x times x, right? What's the derivative? 2x. Is it 1? Therefore, this formula doesn't even work. When f equals x and g equals x, it's no surprising when things become complicated, it doesn't work either. Does it make sense to everybody? Okay, so the second one is correct and this one is wrong. This one is wrong because this formula is wrong. That means from now on, if it's plus and minus, use your common sense. If it's product, the first thing you should reflect in your mind is don't do it. Okay, it's definitely wrong if I just go with my common sense. Sounds good? Okay, we have a whole section in 3.2 to tell you what's the right formula for this. And it is not this, because we just tried it with easy example and it doesn't work. Sounds good? Cool. Then we have no product rule. We cannot do the product. We can only FOIL it out. There's no other way. And then 10x to the fourth plus 6x squared. That's the right answer. And this is wrong. Good, good, good. With that in mind, we have this question. Do you know the derivative of the bottom? Yes. Do you know the derivative of the top? I can do it. It's nothing but a few powers. Good so far? But now you should seriously question yourself. If you do the derivative of both, do you have a quotient rule of just do the top and do the bottom and then divide them? What do you think? If the product rule doesn't work, the quotient rule can't be this easy. Good so far? Therefore, don't even think about it. Don't try to do it separately. Therefore, we only have one way of doing it. Make it a minus and plus. No dividing, no multiplication. We can't handle that. We need special rules. Good news is, it's actually not hard to do. Because no matter how complicated they look, when you finish, it's just a power. Okay. This one is easy. What is this one? Technically, it's x to the negative 1 divided by x squared. How do you combine them? Well, how do you do this? Oh, no, not this one. How do you get this one? You use 6 minus 5, right? Right? Then same thing here. You use x negative 1 minus 2. Then you know this one you use x 1/2 minus 2. 1/2 come from the top, minus 2 from the bottom. Prime. Prime. After that, follow the mechanics. That's the answer. Adam.
For questions like this, I mean, I know this section's not going to be on the exam or anything, but in the future, do you want us to write like the power, like it in a specific order, in like descending order, or?
I won't.
Okay.
But it's a good thing to have because this is how you show other people you're well trained. Right? It's just like when you go to an interview, do you have to dress in business casual? It's the same thing, right? You don't have to, and that creates impressions. So I would suggest for your benefits, write them in decent order if you could. Okay, and also it's going to be easier if you want to do some operation after this. For example, you want to find a horizontal asymptote after this, then descending order is actually helping yourself. But I won't require that. Other questions? Do we get what I'm trying to say here? Number one, we have a power rule. Number two, if it's plus minus, if it's times a constant, feel free to just go with your intuition. But if it's a function times a function divided by a function, you can't do that. Okay, we have a whole section to tell you how to do the product and quotient rule. Okay. And after that, all polynomial is done because we know power, and the polynomial is nothing but power and summation and constant multiplication. The third thing is really quick. The derivative of exponential functions. Okay. This is an exponential function. Including something look like that, something look like that. Okay. Your base can be anything. They're all called exponential. In this section, we only handle this one. The rest, we will get them automatically after we introduce chain rule. So even though we're saying exponential, we're really only handling one exponential here. That is y equals e to the x. Okay. And what is it? Yeah, go with our definition. One thing we should notice is if you have some power, taking the summation is actually this one times that one. The reason we want to do that is we want to take out e to the x. And then because e to the x doesn't have a h, we can take it out. Then our focus should be on this number here. What's the limit? We don't know how to do it. Still okay? The mathematical tool we have so far cannot handle this. So what I am going to do is I'm going to tell you the answer. And what you should do is you should just take out a calculator, plug in h equal to 0.001, see where this number goes. Okay, that is not a proof, but that kind of gives you some kind of feelings, a hint where this number goes. And I'm going to tell you the limit is actually 1. Then the derivative of exponential function with a natural base is itself. That's the formula. Memorize it. We can't give you the proof, and the reason is because we don't know the limit of this. Okay, so we take it for granted. Okay, that's a pretty easy fact to memorize, so we don't have to talk too much about it. For example, I can give an example. What's the derivative of this? And really, it just repeats like e to the x plus 6x. The key is try to memorize the derivative of this one is itself. So there's really no point of giving you more examples. Okay. But one fun fact you can think about this. Okay. That is, we all say exponential function grow really fast. It's kind of like we told you so. Okay. We also say it's faster than any polynomial. Let's just take power. It's faster than x to the cube, x to the fourth, anything. We told you so. Sounds good? But now you can kind of compare what's going on here. For example, you can compare e to the x and x to the cube. Who grows faster? Well, let's compare the derivative. What's going on? Well, the derivative is the same as the function itself. That means the changing rate is the same size as the current function. If I am 1,000 right now, my changing rate is also going to be 1,000. So if I'm already huge, I'm going to grow even faster. Good so far? But now if you look at this, what do you observe? Well, my changing rate is smaller than the original function because every time you take a derivative, your power reduces. Right? Cube become a square. Square become an x. As long as your power reduce, you are not as big as the original size before. Your changing rate is somehow smaller than the current size. That's why exponential is always bigger. If it's not bigger, eventually it will become bigger because the changing rate is way bigger. Sounds good here? Another thing you can think about is what kind of thing grow exponentially? Compound interest. Grow exponentially. Population grows exponentially. Why? That must mean the derivative of the population is the same as the population itself. Make sense so far? That means if you have 1,000 people, the growth rate is roughly 1,000. But if you have 1,000,000 people, which is already bigger than 1,000, and what's worse, the growth rate is bigger than 1,000. It's actually 1,000,000 level. Still okay? So the bigger the population, the even more dramatic of the growth rate. That's why this one is scary. Sounds good? If something is huge, but that derivative is really small, then we don't worry about it because, yeah, you look like 1,000,000 right now, but if I wait for another 1,000 year, you become 1,000,000 plus 2%. Then that's no problem. Your derivative is small. It's still under control. Good so far? The really scary part is when you reach 1,000,000, your growth rate is also that level. That's scary. Okay, that's why exponential is super fast. Okay, that's all we got from 3.1. 3 things to take away. First one, the derivative of this is this. N can be any number, which is real. Second, the derivative of this is this. And the third, f plus g. F times a constant. Okay, that's the 3 things we learned from this section, which is good. We also know that f times g is not f prime times g prime. Surprise or not surprise? F divided g is certainly not f prime divided by g prime. Then our next job is try to do this. The product rule and the quotient rule. How do we do times and the dividing? Let's go with the product first. I'm going to give you the rule. Which is strange or not strange. Does it work? Well, let's check the easy example we had before. Okay, this one. And we know it should be x squared prime equals 2x. Before, if we use the naive rule, we got 1, which is wrong. Okay? But now with the rule here, think about what you're trying to do. This is your f, this is your g, right? So you should have f prime, keep g, plus f, keep f, and do g prime, which give you 1 times x plus x times 1, which give you 2x. It worked for this case. Good. What about the other case, the complicated one? Let's take a look. That was that was x cubed times 2x squared plus 2. Before, what we did is we FOIL everything out, which give you 10x to the 4 plus 6x squared. We use the naive rule, it's wrong. But now let's try our new rule. Because we're new to this, I'm going to write on a table. You don't have to do it for every problem you have from now on. I assign my f to be this. Therefore, my f prime is 3x squared. I assign my g is this. Therefore, my g prime is 4x plus 0. F prime g plus g prime f, which is 3x squared g plus f g prime. 6x to the 4 plus 6x squared plus 4x to the 4th, which is 10x to the 4th plus 6x squared. And this time we have the same answer. That is because we followed the right rule. Sounds good? So your job are the following. Number 1, you need to know this rule firmly. You should have a trigger in your mind. Every time you see times, you just say, hey, don't do it. It's hard. There is a rule. Don't just do whatever you think you want to do. Stop. Write down the rule. Follow. Second, you probably want to, for the first several times, just write down a table to tell you what f is, g is, and then what f prime and g prime is. This is not required, but recommended. Only at the first. Later, you will find this thing super easy, so you don't have to do it. But for now, it's recommended that you try to do a table like this. Okay. Of course, when you get familiar with this, it's super easy. Because basically, you're just saying, hey, I have 2 terms. I only take 1 derivative at a time. Okay. Eventually, you will be as fast as this. You don't need a table. So it's your call. Nick?
Is it okay if you do the first term times the derivative of the second plus the second times the derivative of the first, like just switching it?
You're asking me, I write down this, but can I do this? Okay. Then you should ask yourself, if I have two things, do I have A plus B equals B plus A? And then I believe there is no question. This is definitely doable. Okay. It works for plus. It doesn't work for minus, of course. Sounds good? Okay. This is the rule. I can give you some example, but really there is no point of doing it other than just you go ahead and try it. Probably the harder part is for us to understand why the rule looks like this, right? That's the difficult part. Like, why does the rule, let me put down intuition. That is why this rule. Because if you ask me this, I think it's pretty strange. The changing rate of f times g has something to do with the changing rate of f, I agree. And has something to do with g prime, I agree. But it also has something to do with g and f, the size of original g and f, which I think is pretty weird. I think changing rate is related to changing rate, right? It doesn't matter if you change from 3 to 4 or 7 to 8, you change by 1. But this one clearly tells you you change from 3 to 4 or 7 to 8 makes a difference, even though you changed both by 1. Sounds good here? And then let's try to think about why the formula looks like this. It's actually pretty interesting. So you have d f times g, which is the change of f times g. Later we will talk about changing rate, but for now it's just a change of f times g. We have the change of f, which is df. We have the change of g, which is dg. Okay? Your job is try to figure out when your f change a little bit, when your g change a little bit, how does f times g change? That's your job. Still okay? Now let's think about it. What is f times g? Let's put them here. Let's draw a thing here, and this is f and this is g, make them rectangle. Then this is f times g. That's the area of this rectangle. Good so far? Now you tell me your f change a little bit. Your f become longer. By how much longer? df longer. Now tell me your g change a little bit. It went from here all the way a little bit into here. F changed, d changed. Still okay? Does f times g change? Of course, the area become bigger. What's the change? The change is literally everything in this band. That's how much my area becomes smaller. When your f change a little bit, your g changes a little bit, actually my whole thing change a lot. Sounds good? Second, what I'm going to do is I'm going to divide the change into 3 parts. The part changed because of f, the part changed because of d and g. So let's do a decomposition by doing this cut. So we have area 1, we have area 2, we have area 3. Okay. This is the first area. How big is it? It's dg and f, therefore it's f times dg. Okay. Your g changed a little bit, your area changed this much. Even your f doesn't change, your area is going to change this much. This is 1. This is 3. You have g and df. Therefore, it's g times df. Even if your g doesn't change, as long as your f change a little bit, you change this much. You don't just change f, you change f times g. And of course, there is a second part. A little tiny square right there is actually dg and df. Still okay? So by simple area, we have d f dot g, the change of f times g, equals area 1 plus area 2 plus the last small little square. That's the change. How to make it the change in rate? You divide by dx. Okay, on the left, change in rate. On the right, the two things divided by dx, I on purposely wrote these two together, which you can do. And then I on purpose wrote these two together, which you still can do. Good so far? The last one doesn't matter. Write whichever way you prefer. I just chose this, but feel free to switch and put dg here and df there. It doesn't really matter. And now you see this is f g prime plus g f prime. Okay, which is our product rule already, right? That means the last part has to be 0. Why? This is g prime. Still okay? What is df? df is 0. Because we're letting dx goes to 0, d anything is 0. So this part is neglectable. Therefore, we have this. D prime f, yes. And plus is gone because it's too small. Take your notes, read through it. Hopefully after that, the whole formula makes sense to you, so you don't have to recite it letter by letter. Now it has some meaning. Okay? And that's all for today. I will stay here for questions.